Our journey begins with the heart of our solar system, the Sun. A colossal, fiery orb that has nurtured life on Earth for over 4.6 billion years. Today, we venture closer than ever before to this magnificent star, the very source of energy that fuels our planet and shapes the destiny of every living being within its grasp. As we approach the Sun, the first thing that strikes us is its overwhelming presence. At a staggering 1.4 million kilometers in diameter, it could fit over 1 million Earths within its volume. The Sun is not a solid object, but a massive ball of glowing plasma, a state of matter where electrons are stripped from atoms, creating a sea of charged particles. It is this plasma that generates the Sun's incredible heat and light. The Sun's surface, known as the photosphere, is a churning sea of energy, with temperatures reaching around 5,500 degrees Celsius. This may seem intense, but it's just the beginning. Above the photosphere lies the Sun's atmosphere, consisting of the chromosphere and the corona. The corona, a halo of plasma, extends millions of kilometers into space and reaches temperatures of over 1 million degrees Celsius, hotter than the surface itself. This paradox has puzzled scientists for decades, and it remains one of the Sun's greatest mysteries. Let us descend now, metaphorically, into the core of the Sun, the true powerhouse. Here, at the center, where temperatures soar to about 15 million degrees Celsius, nuclear fusion takes place. Hydrogen atoms, under immense pressure, collide and fuse to form helium, releasing vast amounts of energy in the process. This energy takes a long and arduous journey, up to 1 million years, to reach the Sun's surface, but once it escapes, it travels through the vacuum of space to bathe the Earth in sunlight in just over 8 minutes. The Sun is a dynamic entity, constantly in motion and in flux. The photosphere is marked by dark patches known as sunspots, regions where magnetic fields are particularly strong and temperatures are slightly cooler than the surrounding areas. These sunspots can give rise to powerful solar flares and coronal mass ejections, which send streams of charged particles hurtling through space. When these particles collide with Earth's magnetic field, they create spectacular displays of light, auroras, at the poles. The Sun's influence extends far beyond its immediate vicinity. Its gravitational pull keeps the entire solar system in order, guiding the planets in their elliptical orbits. But the Sun is also in a delicate balance, maintaining equilibrium between the outward pressure from fusion reactions and the inward pull of gravity. This balance ensures the Sun's stability, but it won't last forever. In about 5 billion years, the Sun will exhaust its hydrogen fuel and undergo dramatic changes. It will swell into a red giant, engulfing the inner planets, including Earth. Eventually, it will shed its outer layers, leaving behind a dense, hot core, a white dwarf, that will slowly cool over billions of years. But for now, the Sun remains a relatively stable and life-giving star. It is easy to take for granted, yet without it, life on Earth would be impossible. Every breath we take, every ray of light that warms our skin, every crop that grows, all of it is owed to this magnificent star. As we prepare to leave the Sun, one cannot help but feel a sense of awe and gratitude. The Sun, with its immense power and energy, is both a giver and taker of life. It is a constant reminder of the delicate balance that sustains our planet and the fleeting nature of existence in the cosmos. And so, we continue our journey, venturing outward to the planets that dance in the Sun's gravitational embrace. But no matter how far we travel, the Sun will always be the anchor, the glowing heart of our solar system, silently guiding and nurturing us from 150 million kilometers away. Let's continue our journey to the next planet in the solar system, Mercury. Mercury, the smallest planet in our solar system and the closest to the Sun, is a world of extremes. Its proximity to our star means that it experiences some of the most intense conditions in the entire solar system. As we approach Mercury, the first thing we notice is its stark, barren landscape, a testament to the harsh environment it endures. Despite its close orbit around the Sun, Mercury is not the hottest planet in our solar system. That title belongs to Venus. However, Mercury experiences the most significant temperature fluctuations. During the day, the Sun's intense radiation heats Mercury's surface to blistering temperatures of up to 430 degrees Celsius. But at night, without a substantial atmosphere to retain heat, temperatures plummet to a bone-chilling -180 degrees Celsius. This drastic change between day and night highlights the planet's extreme environment. Mercury's surface is scarred with countless craters, much like our Moon. These impact craters are the result of collisions with asteroids and comets over billions of years. One of the most prominent features is the Caloris Basin, a massive impact crater that stretches 1,550 kilometers across. The force of the impact that created the Caloris Basin was so powerful that it caused seismic waves to ripple through the planet, creating hilly and uneven terrain on the opposite side of Mercury. As we glide over Mercury's surface, we also notice vast plains, known as intercrater plains, that were formed by ancient volcanic activity. Though Mercury is now geologically inactive, these plains serve as a reminder of the planet's dynamic past. Some regions also feature steep cliffs or scarps, which can rise up to several kilometers high and stretch for hundreds of kilometers. These scarps are believed to have formed as the planet's interior cooled and contracted over time, causing the crust to crack and buckle. Mercury's orbit is another fascinating aspect of this tiny planet. It is the most elliptical of all the planets in our solar system, meaning its distance from the Sun varies significantly during its orbit. At its closest approach, known as perihelion, Mercury is just 46 million kilometers from the Sun. At its farthest, or aphelion, it is 70 million kilometers away. This eccentric orbit, combined with the planet's slow rotation, leads to unusual day-night cycles. One solar day on Mercury, the time it takes for the Sun to return to the same position in the sky, lasts about 176 Earth days. In contrast, Mercury's year, the time it takes to complete one orbit around the Sun, is only 88 Earth days. Mercury's proximity to the Sun also means it experiences the strongest gravitational pull from our star. This has led to a phenomenon known as tidal locking, where Mercury's rotation has slowed down over time due to the Sun's gravitational influence. While Mercury is not fully tidally locked like our Moon, it has a 3:2 spin-orbit resonance, meaning it rotates 3 times on its axis for every 2 orbits around the Sun. As a result, if you were standing on the surface of Mercury, you would see the Sun rise, set, and then rise again before it finally moves across the sky. Interestingly, despite being so close to the Sun, Mercury has no moons. Its small size and the Sun's powerful gravity likely prevented it from capturing any natural satellites. Instead, Mercury orbits alone, constantly battered by solar winds and cosmic debris. The lack of a substantial atmosphere on Mercury is another factor that sets it apart from Earth. While Earth's atmosphere protects us from meteoroids, regulates temperature, and supports life, Mercury's atmosphere is incredibly thin, composed mainly of oxygen, sodium, hydrogen, helium, and potassium. This exosphere, as it's known, is so tenuous that particles within it are more likely to escape into space than remain bound to the planet. Without a protective atmosphere, the surface of Mercury is directly exposed to the harsh environment of space. Mercury's small size and proximity to the Sun have made it a challenging target for exploration. However, despite these difficulties, we have managed to send a few spacecraft to study this enigmatic world. NASA's Mariner 10 was the first mission to visit Mercury, conducting flybys in the 1970s and providing the first close-up images of the planet. More recently, the Messenger mission orbited Mercury from 2011 to 2015, mapping its surface in detail and uncovering new insights into its composition, magnetic field, and geological history. Among the most surprising discoveries was evidence of water ice in permanently shadowed craters at Mercury's poles, a stark contrast to the scorching temperatures experienced elsewhere on the planet. Mercury's magnetic field is another area of interest for scientists. While it is much weaker than Earth's, it is still significant, especially for such a small planet. This magnetic field, generated by a partially molten core, helps to deflect some of the solar wind, though Mercury's proximity to the Sun means it is still bombarded by a constant stream of charged particles. These interactions between the magnetic field and solar wind create a dynamic and ever-changing space environment around Mercury. As we prepare to leave Mercury, one cannot help but marvel at the resilience of this small planet. Despite its proximity to the Sun and the harsh conditions it endures, Mercury remains a fascinating and valuable subject of study. It offers us a glimpse into the early history of our solar system and the processes that have shaped the planets we see today. Our journey now takes us away from the searing heat of Mercury, toward the other worlds that orbit our Sun. But the lessons we've learned here, about the extremes of temperature, the impact of solar radiation, and the dynamics of planetary geology, will stay with us as we continue our exploration of the solar system. As we travel further from the Sun, we arrive at Venus, often referred to as Earth's twin. But this seemingly familiar world is a place of extremes, where the similarities to our planet are overshadowed by a nightmarish reality. Venus, shrouded in thick clouds of sulfuric acid, is a hostile world where surface temperatures can melt lead, and the atmospheric pressure is crushing. Venus is nearly the same size as Earth, and for a long time, it was thought that Venus might harbor life or at least conditions similar to those on our planet. However, as we peer through the dense clouds that blanket Venus, the truth is far more harrowing. The planet's atmosphere is composed almost entirely of carbon dioxide, with clouds of sulfuric acid, making it a greenhouse hellscape. This runaway greenhouse effect has trapped heat on the planet, leading to surface temperatures of around 465 degrees Celsius, hotter than Mercury, despite being farther from the Sun. The surface of Venus is a barren, volcanic landscape. It is dotted with large shield volcanoes, vast lava plains, and deformed mountain ranges. The lack of erosion due to the absence of liquid water and the stifling atmosphere has preserved these features for hundreds of millions of years. Volcanism on Venus is thought to be still active, though the planet's thick atmosphere and cloud cover make it difficult to confirm recent eruptions. One of the most striking features of Venus is its slow, retrograde rotation. Venus takes 243 Earth days to complete one rotation on its axis, and it rotates in the opposite direction to most other planets in the solar system. This means that on Venus, the Sun rises in the west and sets in the east. Interestingly, a day on Venus, one complete rotation, is longer than a Venusian year, one orbit around the Sun, which takes only 225 Earth days. Venus also lacks a magnetic field, which is surprising for a planet of its size. Scientists believe that this is because Venus has a slow rotation, which may not generate the necessary dynamo effect in its core. Without a magnetic field, Venus is vulnerable to the solar wind, which strips away particles from its atmosphere, though the planet's dense atmosphere still acts as a formidable shield. Exploring Venus has proven to be a monumental challenge. The Soviet Union's Venera missions in the 1960s and 70s were the first to land on the surface of Venus, but the harsh conditions quickly destroyed the spacecraft. Despite these difficulties, the data collected provided invaluable insights into the planet's surface and atmosphere. More recently, NASA and other space agencies have proposed new missions to study Venus, focusing on its climate, geology, and potential for past habitability. The mysteries of Venus continue to captivate scientists. Despite its hellish conditions, there are theories that microbial life could exist in the upper atmosphere, where temperatures and pressures are more Earth-like. The discovery of phosphine, a potential biosignature, in Venus's atmosphere has sparked renewed interest in this possibility, though the findings remain controversial and subject to further investigation. As we leave Venus, we are reminded of the delicate balance that sustains life on Earth. Venus serves as a cautionary tale of what can happen when a planet's atmosphere spirals out of control, leading to a world that is hostile and uninhabitable. Our journey now takes us to a more familiar world, one that we call home. Earth. As we arrive at Earth, we are greeted by the sight of a world teeming with life. Earth is unique in our solar system, a planet with vast oceans, lush forests, and a diverse array of life forms that have evolved over billions of years. It is a world where the delicate interplay of atmosphere, water, and land has created an environment that is just right for life. Earth's atmosphere is a complex mixture of gases, primarily nitrogen and oxygen, with trace amounts of carbon dioxide, water vapor, and other gases. This atmosphere not only provides the air we breathe but also regulates the planet's temperature through the greenhouse effect. Unlike Venus, Earth's greenhouse effect is moderate, allowing for a range of climates that support life. The ozone layer, a thin shield of ozone molecules in the stratosphere, protects life on Earth from the sun's harmful ultraviolet radiation. Earth's surface is dynamic and ever-changing, shaped by the forces of plate tectonics, erosion, and weathering. The planet's crust is divided into several large plates that float on the semifluid mantle beneath. These plates move slowly, driven by the heat from Earth's interior, causing earthquakes, volcanic eruptions, and the formation of mountains and ocean basins. Water is the lifeblood of Earth. Covering over 70% of the planet's surface, Earth's oceans are home to a vast array of marine life and play a crucial role in regulating the planet's climate. The water cycle, driven by the sun's energy, ensures that water is continuously cycled between the oceans, atmosphere, and land, sustaining life in all its forms. Earth's magnetic field is another vital feature that sets it apart from other planets. Generated by the movement of molten iron in the planet's outer core, this magnetic field extends far into space, creating a protective bubble known as the magnetosphere. The magnetosphere shields Earth from the solar wind, deflecting charged particles and preventing them from stripping away the atmosphere. It also gives rise to the stunning auroras, as charged particles from the Sun collide with Earth's magnetic field near the poles. Earth's diverse ecosystems are home to millions of species, each uniquely adapted to their environment. From the icy tundras of the Arctic to the lush rainforests of the Amazon, life on Earth has evolved to thrive in a wide range of habitats. The biosphere, the sum of all living organisms on Earth, interacts with the atmosphere, hydrosphere, and lithosphere in a complex web of relationships that sustain life. But Earth is not without its challenges. Human activity has significantly altered the planet's environment, leading to climate change, deforestation, pollution, and loss of biodiversity. The delicate balance that sustains life on Earth is under threat, and the need for sustainable practices and conservation efforts has never been more urgent. As we leave Earth, we are reminded of its fragility and the responsibility we have to protect this unique and precious world. Our journey now takes us to the red planet, Mars, a world that has long captured the imagination of scientists and dreamers alike. Mars, the fourth planet from the Sun, has been the subject of fascination for centuries. Known as the red planet due to its rusty, iron-rich surface, Mars has inspired countless myths, stories, and scientific endeavors. Today, as we approach this enigmatic world, we are on the cusp of answering one of humanity's greatest questions: could there be, or have there ever been, life on Mars? Mars is a cold, desert world, with an atmosphere that is thin and composed mostly of carbon dioxide. The surface is barren and rocky, covered with dust that gives the planet its characteristic red hue. Despite the harsh conditions, Mars is home to some of the most dramatic landscapes in the solar system. The planet is dominated by vast plains, towering volcanoes, and deep canyons that hint at a more dynamic past. One of the most prominent features on Mars is Olympus Mons, the largest volcano in the solar system. Standing at 22 kilometers high and spanning 600 kilometers in diameter, Olympus Mons dwarfs any mountain on Earth. This massive shield volcano is a testament to Mars's volcanic activity, though it is believed to be dormant now. Nearby, the Tharsis region is home to a number of other large volcanoes, each a reminder of the planet's fiery past. Valles Marineris, a colossal canyon system that stretches for over 4,000 kilometers, is another of Mars's remarkable features. This immense rift valley is thought to have formed through tectonic activity, as the planet's crust cracked and pulled apart. At its deepest point, Valles Marineris plunges 7 kilometers into the Martian surface, creating a vast chasm that dwarfs Earth's Grand Canyon. Mars's surface is also marked by evidence of ancient river valleys, lake beds, and deltas, suggesting that liquid water once flowed across the planet. These features, along with the discovery of hydrated minerals and underground ice, have fueled speculation about the possibility of past life on Mars. Scientists believe that Mars may have had a more Earth-like climate in the distant past, with a thicker atmosphere and stable bodies of water on its surface. Mars's thin atmosphere, however, is unable to support liquid water today. The planet's low atmospheric pressure and cold temperatures cause any water on the surface to quickly evaporate or freeze. Despite this, recent discoveries of recurring slope lineae, dark streaks that appear on Martian slopes during warmer seasons, suggest that liquid water may still exist in small quantities, perhaps as briny flows beneath the surface. The search for life on Mars has been a driving force behind many missions to the planet. NASA's Viking missions in the 1970s were the first to search for signs of life, conducting experiments on the Martian soil. While the results were inconclusive, they paved the way for future exploration. More recent missions, such as the Curiosity rover and the Perseverance rover, have continued the quest, searching for signs of past microbial life and collecting samples that could one day be returned to Earth. Mars's two small moons, Phobos and Deimos, add to the planet's intrigue. These irregularly shaped moons are thought to be captured asteroids, and their origins remain a topic of scientific debate. Phobos, the larger of the two, orbits Mars so closely that it appears to rise and set twice in a single Martian day. Both moons are heavily cratered and covered in a layer of dust and debris, remnants of their tumultuous past. As we prepare to leave Mars, we are reminded of the planet's potential to answer some of the most profound questions about life beyond Earth. Mars is a world of contrasts, ancient and young, familiar and alien, dead and possibly alive. Our exploration of Mars is still in its early stages, But with each mission, we come closer to unraveling the mysteries of the red planet. Our journey now takes us further from the Sun, to the giant planets that dominate the outer solar system. The next stop on our voyage is Jupiter, the largest planet in our solar system and a world of immense power and beauty. Jupiter, the majestic giant. Our journey now brings us to Jupiter, the largest and most massive planet in our solar system. Jupiter is a colossus, an awe-inspiring world that dwarfs all others in size and mass. With a diameter of about 143,000 kilometers, it is more than 11 times wider than Earth and has a mass that is over 300 times greater. As we approach Jupiter, the first thing that captures our attention is its striking appearance. The planet's atmosphere is a tapestry of swirling clouds in hues of orange, brown, white, and red. These bands are the result of differential rotation and the complex interplay of various gases within Jupiter's atmosphere. The planet is surrounded by immense storm systems and turbulent weather patterns, creating a dynamic and ever-changing environment. Jupiter's most famous feature is the Great Red Spot, a massive storm that has been raging for at least 400 years. This enormous anticyclone is so large that 3 Earths could fit inside it. The Great Red Spot is a dramatic example of Jupiter's powerful weather systems, which are driven by the planet's rapid rotation and internal heat. Jupiter rotates on its axis once every 10 hours, creating strong atmospheric currents that contribute to the formation of these impressive storms. The planet's atmosphere is composed mainly of hydrogen and helium, with trace amounts of methane, ammonia, and water vapor. Deep within the atmosphere, the pressure and temperature rise dramatically, creating conditions where hydrogen exists in a metallic state. This metallic hydrogen is a key component of Jupiter's interior and plays a crucial role in generating the planet's strong magnetic field. Jupiter's magnetic field is the most powerful of any planet in our solar system. It is created by the movement of metallic hydrogen within the planet's interior and extends millions of kilometers into space. This magnetic field creates intense radiation belts and influences the behavior of Jupiter's many moons. Jupiter is orbited by 79 known moons, the 4 largest of which are known as the Galilean moons, Io, Europa, Ganymede, and Callisto. These moons were first observed by the astronomer Galileo Galilei in 1610 and are among the most intriguing objects in the solar system. Each of these moons has its own unique characteristics. Io, the most geologically active body in the solar system, Io is covered with volcanoes and sulfurous compounds. Its surface is constantly reshaped by volcanic eruptions, making it a dynamic and ever-changing world. Europa is an icy moon with a surface that is thought to cover a subsurface ocean of liquid water. The surface is marked by cracks and ridges, suggesting that the ocean beneath may be in contact with Europa's rocky mantle, creating a potential environment for life. Ganymede, the largest moon in the solar system, Ganymede is even larger than the planet Mercury. It has a magnetic field of its own and is believed to have a subsurface ocean, adding to the list of intriguing worlds in Jupiter's orbit. Callisto, the most heavily cratered moon in the solar system, Callisto's surface is ancient and shows little evidence of geological activity. It also likely harbors a subsurface ocean beneath its icy crust. Jupiter's ring system, while not as prominent as Saturn's, is still notable. The rings are composed of dark, dusty particles and were discovered by the Voyager spacecraft. They are faint and consist of 3 main components: the halo, the main ring, and the gossamer ring. As we prepare to depart from Jupiter, we are left in awe of its grandeur and complexity. The planet's immense size, powerful storms, and intriguing moons make it a true giant among the planets of our solar system. Jupiter's influence extends far beyond its immediate vicinity, shaping the dynamics of its moons and contributing to the broader cosmic environment. Our exploration now leads us to Saturn, a world renowned for its magnificent rings and fascinating moons. As we continue our journey, each planet reveals new facets of its nature, adding to the rich tapestry of our solar system. Saturn, the ringed beauty. As we journey further into the solar system, we arrive at Saturn, the sixth planet from the Sun and one of the most iconic and magnificent worlds in our cosmic neighborhood. Saturn is renowned for its stunning ring system, which sets it apart from all other planets. Saturn, a gas giant with a diameter of approximately 120,000 kilometers, is the second largest planet in our solar system, after Jupiter. Like its giant neighbor, Saturn's atmosphere is composed primarily of hydrogen and helium, with traces of methane, ammonia, and other gases. This composition gives Saturn its characteristic pale yellow color, which results from the reflection of sunlight by its gaseous layers. The most striking feature of Saturn is its extensive ring system. Composed of countless ice particles and rocky debris, these rings are incredibly diverse. The largest and most prominent rings are divided into several major sections, A, B, and C. The A and B rings are the brightest and most easily visible, while the C ring is fainter and closer to the planet. In addition to these main rings, Saturn has several fainter rings and gaps, including the famous Cassini division, a gap between the A and B rings caused by the gravitational influence of Saturn's moon Mimas. Saturn's rings are not a uniform structure but are composed of a complex mixture of particles ranging in size from tiny grains to large chunks several meters across. The particles in the rings are mostly water ice, with varying amounts of dust and rock. These icy particles reflect sunlight, creating the dazzling appearance of Saturn's rings. The rings are not solid, instead, they are made up of countless individual particles orbiting the planet in their own paths. Saturn's atmosphere, while more tranquil compared to Jupiter's, still exhibits dynamic weather patterns. The planet experiences strong winds and has a system of banded clouds that move at different speeds. Saturn's famous hexagonal storm at its north pole is a particularly fascinating feature. This six-sided storm system, first observed by the Voyager spacecraft, is a result of complex atmospheric dynamics and remains one of the most enigmatic and visually striking phenomena in the solar system. Saturn is home to 83 known moons, making it the planet with the most moons in the solar system. The largest of these moons, Titan, is a world unto itself. Titan is the second largest moon in the solar system and has a thick atmosphere composed primarily of nitrogen, with traces of methane. This atmosphere creates a dense, hazy orange glow, and Titan is known to have lakes and rivers of liquid methane and ethane on its surface. The presence of these hydrocarbons suggests that Titan could have an environment similar to early Earth, and it remains a prime candidate for further exploration. Another intriguing moon of Saturn is Enceladus. This icy moon has a subsurface ocean beneath its frozen crust. Geysers of water vapor and ice particles erupt from its south pole, indicating the presence of liquid water beneath the surface. These plumes have been studied by the Cassini spacecraft and are thought to be connected to a global ocean of liquid water, making Enceladus a significant target for the search for extraterrestrial life. Saturn's magnetic field, generated by the movement of metallic hydrogen in its interior, is less intense than Jupiter's but still powerful. This magnetic field, combined with the planet's rotation, creates an intricate system of radiation belts and interacts with the solar wind to produce auroras at the poles. As we prepare to leave Saturn, we are reminded of its extraordinary beauty and complexity. The planet's rings, moons, and atmospheric phenomena showcase the diversity of our solar system and the many wonders that await exploration. Saturn stands as a symbol of the magnificence that exists beyond our own world, inviting us to continue our journey through the cosmos. Our next destination takes us to the icy realms of Uranus, where we will explore yet another intriguing and enigmatic world. Each planet we visit adds to our understanding of the solar system, revealing the breathtaking diversity and complexity that define our celestial neighborhood. Uranus, the tilted giant. As we continue our journey outward in the solar system, we arrive at Uranus, a planet that stands out for its unique characteristics. Discovered in 1781 by the astronomer William Herschel, Uranus is a world of intriguing contrasts and mysteries, known for its unusual tilt and striking blue-green color. Uranus, the seventh planet from the Sun, is a gas giant with a diameter of about 50,000 kilometers. It is one of the two ice giants in our solar system, along with Neptune. Unlike Jupiter and Saturn, which are primarily composed of hydrogen and helium, Uranus's atmosphere is dominated by water, ammonia, and methane. The presence of methane gives Uranus its distinctive blue-green hue, as the gas absorbs red light and reflects blue and green. One of the most extraordinary features of Uranus is its extreme axial tilt. The planet is tilted on its side by approximately 98 degrees, meaning it essentially rolls along its orbit like a barrel. This unusual tilt causes extreme seasonal variations, with each pole experiencing 42 years of continuous sunlight followed by 42 years of darkness. The reason for this dramatic tilt is still not entirely understood, but it is believed to be the result of a massive collision with another celestial body early in Uranus's history. The atmosphere of Uranus is relatively calm compared to the stormy conditions of its neighbor Neptune. However, the planet does experience strong winds and some meteorological activity. The upper atmosphere features bands of clouds that move at different speeds, creating a banded appearance. Uranus also has a faint ring system composed of dark, icy particles. These rings are much less pronounced than those of Saturn but add to the planet's enigmatic nature. Beneath the atmosphere lies the icy mantle of Uranus, which consists of a mixture of water, ammonia, and methane. This mantle surrounds a rocky core, though the exact composition and structure of the core are still subjects of scientific investigation. The high pressures and temperatures within Uranus's interior create conditions that are unlike those found on other planets. Uranus has a collection of 27 known moons, each with its own unique characteristics. The five largest moons, Miranda, Ariel, Umbriel, Titania, and Oberon, are named after characters from the works of William Shakespeare and Alexander Pope. Miranda, the innermost of these moons, is particularly notable for its bizarre and varied terrain, which includes giant canyons and ridges that suggest a history of intense geological activity. The Voyager 2 spacecraft, which flew by Uranus in 1986, provided the first close-up images of the planet and its moons. These images revealed a world of contrasts, with some moons showing evidence of past tectonic activity and others exhibiting icy surfaces covered in craters. The data collected by Voyager 2 also revealed the presence of a magnetic field, which is tilted with respect to Uranus's rotation axis. This magnetic field, combined with the planet's tilt, creates complex interactions between the planet's atmosphere and its magnetic environment. As we prepare to leave Uranus, we are reminded of the planet's distinctive and enigmatic nature. Its extreme tilt, unique atmospheric composition, and intriguing moons make it a fascinating object of study. Uranus serves as a reminder of the diversity and complexity that exists within our solar system, offering insights into the formation and evolution of gas giants. Our exploration continues as we move farther out, venturing toward the icy realms of Neptune. Each planet we visit adds a new layer to our understanding of the solar system, showcasing the vast array of wonders that lie beyond our own world. Neptune, the windy giant. Our journey now takes us to the distant, enigmatic world of Neptune, the eighth and farthest planet from the Sun, discovered in 1846. Neptune is a world cloaked in mystery, surrounded by swirling blue clouds and fierce winds that make it one of the most intriguing destinations in our solar system. As we approach Neptune, the first thing that captures our attention is its striking blue hue. This vivid color is not merely a visual delight but a result of the planet's atmospheric composition. Neptune's atmosphere is primarily made up of hydrogen and helium, with traces of methane. It is this methane that absorbs red light and reflects blue, giving Neptune its characteristic azure appearance. But there's much more beneath this beautiful surface. Neptune is a gas giant, similar in structure to Uranus, but with more dynamic and violent weather patterns. The planet's atmosphere is known for its high-speed winds, which can reach speeds of up to 2,100 kilometers per hour. These winds make Neptune the windiest planet in our solar system, creating storm systems and dark spots that resemble giant cyclones. One of the most famous features of Neptune is the Great Dark Spot, a colossal storm system that was first observed by the Voyager 2 spacecraft in 1989. This storm, comparable in size to Earth, showcases Neptune's intense meteorological activity. Though the Great Dark Spot has since changed and evolved, it remains a testament to the planet's tumultuous weather. Neptune's interior is just as fascinating as its atmosphere. Deep beneath the clouds lies a layer of water, ammonia, and methane ice, referred to as the icy mantle. This mantle surrounds a core that is thought to be composed of rock and metal. The pressure within Neptune's interior is immense, and the exact nature of its core remains a subject of ongoing research. Neptune has a faint and complex ring system, consisting of 5 main rings and several faint arcs. These rings are composed primarily of ice particles and dust, with varying levels of brightness and density. The discovery of these rings adds another layer of intrigue to this remote world, showcasing its dynamic and ever-changing nature. Despite its distance from the Sun, Neptune has been the subject of considerable scientific interest. The Voyager 2 spacecraft provided our first close-up images of Neptune and its moons, revealing a world of stunning beauty and complexity. Among Neptune's moons, Triton stands out as a particularly fascinating object. Triton is one of the few moons in the solar system known to have a retrograde orbit, meaning it orbits Neptune in the opposite direction of the planet's rotation. This unusual orbit suggests that Triton may have been captured by Neptune's gravity and was not originally formed in orbit around the planet. Triton's surface is covered in a layer of frozen nitrogen, with geysers that erupt and spew plumes of gas into space. These geysers are believed to be driven by internal heat, possibly from tidal forces or radioactive decay. Triton's geological activity and unique characteristics make it a prime candidate for future exploration. Neptune's distance from the Sun means that it receives very little solar energy, resulting in a frigid environment. Yet, despite these cold temperatures, Neptune's atmospheric dynamics are driven by complex interactions between solar radiation and internal heat sources. This interplay creates a dynamic and ever-evolving climate that continues to captivate scientists. As we prepare to leave Neptune, we are reminded of the vastness and diversity of our solar system. Neptune, with its powerful storms, mysterious rings, and intriguing moons, stands as a testament to the wonders that lie at the edge of our cosmic neighborhood. Its distant, icy expanse invites us to continue exploring, seeking out the secrets that lie beyond our current reach. And so, our journey through the solar system comes to a close. From the blazing heart of the Sun to the icy fringes of Neptune, we have traversed a vast and varied landscape, each planet offering its own unique insights and beauty. As we return to Earth, we carry with us the knowledge and wonder of these distant worlds, reminding us of the boundless mysteries that await our exploration in the cosmos. As we conclude our extraordinary voyage through the solar system, we reflect on the incredible worlds we have explored and the marvels we have encountered. Our journey has taken us from the blazing heart of the solar system to the icy fringes of its outer reaches, revealing the diverse and wondrous nature of our cosmic neighborhood. We began our trip with the Sun, the central star that anchors our solar system. We witnessed its immense power and influence, understanding how it fuels the planets and drives the dynamics of the solar system. The Sun's energy shapes the climates and weather patterns of the planets and is the source of life-giving warmth for Earth. Our first planetary stop was Mercury, the closest planet to the Sun. We explored its extreme temperatures, lack of atmosphere, and the impact of its proximity to the Sun on its surface conditions. Mercury's surface, marked by craters and vast plains, tells the story of a planet battered by cosmic impacts and solar radiation. Next, we journeyed to Venus, Earth's enigmatic twin. With its thick, toxic atmosphere and scorching surface temperatures, Venus presents a stark contrast to our own planet. Its beauty is veiled by clouds of sulfuric acid, and its surface is a furnace where temperatures soar to extreme heights. As we arrived at Earth, our home, we marveled at the unique conditions that make it a cradle of life. Earth's vibrant landscapes, dynamic weather systems, and rich biodiversity set it apart as a haven in the vast expanse of space. Our exploration underscored the importance of preserving and cherishing our planet. Our adventure continued to Mars, the red planet, where we examined its iron oxide surface, towering volcanoes, and the potential for past life. Mars's diverse features, including the massive Olympus Mons and the vast Valles Marineris, invite us to consider the possibilities of future exploration and the search for life beyond Earth. We then traveled to Jupiter, the gas giant that dominates the solar system with its immense size and powerful storms. Jupiter's Great Red Spot and extensive moon system, including the intriguing Galilean moons, offered a glimpse into the planet's dynamic atmosphere and complex satellite system. Saturn, with its breathtaking rings and numerous moons, was our next destination. We admired the intricate structure of its rings and explored the unique characteristics of its moons, such as Titan and Enceladus, which hold secrets of their own. Continuing our journey, we arrived at Uranus, the ice giant with its peculiar tilt and faint rings. Uranus's atmospheric composition and its collection of moons provided insights into the nature of ice giants and the diversity of planetary systems. Finally, we reached Neptune, the blue giant at the edge of the solar system. Neptune's intense winds, dynamic storms, and intriguing moons like Triton highlighted the remote and enigmatic nature of this distant world. As we prepare to return home, we reflect on the grandeur and diversity of the solar system. Each planet and the Sun have contributed to our understanding of the cosmos, revealing the complex and interconnected nature of our celestial neighborhood. Our journey has deepened our appreciation for the vastness of space and the myriad wonders it holds. Returning to Earth, we bring with us the knowledge and inspiration gained from this remarkable exploration. Our voyage through the solar system has been a testament to the beauty and complexity of the universe, reminding us of our place within it and the ongoing quest to explore and understand the cosmos. Thank you for joining us on this extraordinary journey. As we look up at the night sky, we are reminded of the countless worlds waiting to be explored and the endless possibilities that lie beyond our own planet. Until our next cosmic adventure, may the stars continue to inspire and guide us.